Hey guys, this is the second free fall problems video. I'm going to do two problems. These are definitely more difficult than the last two. And yeah, just give you some more exposure. So this problem here is number 45, or excuse me, number 49 on page 45 in your book. It says a stone is thrown vertically upward with a speed of 12 meters per second from the edge of a cliff 75 meters high. How much later does it reach the bottom of the cliff? All right, so he's throwing this rock up with an initial speed. It reaches its peak, and then it falls back down and it hits the ground. All right, there's three questions it asks. When does it hit the ground? How fast is it going when it hits the ground? And what is the total distance it travels? All right, so I've looked up the answers to these in the back, just so we can check ourselves as we go. They are here on the right. Make sure I'm straight here, and let's tackle it. We are in free fall. We know the initial velocity. We know the acceleration, negative 9.8 meters per second squared. And we know our positions, right? So it is throwing it from the top of this 75-meter cliff, and it ends on the ground. So I would say that we should call the ground to be the origin, and saying that the initial position is 75. So the initial position is 75 meters, and the final position is 0. All right, and so we want to know the time. So the first one, we're trying to find the time. This is for part A. Find time. And looking at our equations, right? One thing about all of these three equations is that you need to know the final velocity, and we do not know the final velocity. We do not know how fast it's going when it hits the ground. So we can't use any of those three. So we are stuck with using the second one. So let's fill it out. Y, because we're vertical. V naught t, 1/2 at squared, right? This is A is g. So we know the y is 0. Yep. And the initial is 75 meters plus. Now this is different because our initial velocity is not 0, so it will not cancel out. 1/2 negative 9.8 meters per second squared times squared. All right, and so what we have here is we have a quadratic equation, right? 0 equals 75 plus some function of t and some function of t squared. And so we do need to solve the quadratic formula. We know that a, which is our t squared term, is going to be negative 4.9. B is going to be 12, and c is going to be 75. So we're going to go ahead and solve for the roots, solve for the time. So we have negative b. Well, let's go ahead and write it. Plus or minus square root b squared minus 4ac all over 2a. Sorry, make sure I don't drift here. I have to look back to make sure that it's straight. So if I go crooked, sorry about that. So let's fill her in. Negative b is negative 12. Plus or minus the square root of b squared, which is 144, minus 4 times negative 4.9 times 75, right? So 4 times 75 is 300. 300 times 4.9, 3 times 4 is, that should be 1470. This is all over 2 times negative 4.9. All right, what's the square root of 1470? Is that right? 38.3. Okay. Oh, I need to add the 144. So this square root comes out to 40.17. I know y'all can do this in your calculator. Over negative 9.8. We are going to get two roots. We want the positive root. So we are dividing by a negative number, so we want this top number to be negative. So we're going to do negative 12 minus 40.17 over negative 9.8. And computing that out, and you get 5.32, yeah, that can be 5.33. Within rounding, I got 5.324. So yeah. And this is the time. So. And there's the time, right? So it's I mean it's just like the last one. It's just the math is harder, right? So you gotta do the quadratic formula. And that does match our answer, so that's reassuring. For the second part, we need to find how fast it's going at the bottom, so the final velocity. And that one is much simpler. I'm going to turn the page. I should have did this on a 2-page. I was planning ahead. So for part B, we're going to find the final velocity. And this one we can simply use velocity as initial velocity plus acceleration time. It was thrown up with positive 12. Minus 9.8 meters per second squared times the time, which is 5.33 seconds. So the final velocity is sorry about that. 9.8. Negative 40.2. And that good. 40.2. Did it ask for? It does ask for speed. The problem does say what is its speed just before hitting the ground. So the velocity is negative because it's going downwards. We can say that the speed is positive, right? 40.2. Notice that we can use this formula even though it was on its way down, right? So you may think that, well, it was thrown upwards with an initial velocity and then it comes to a stop and then it came back down. That simple formula will take care of all that, no problem. Last thing, C, is to find the total distance that it traveled. So it traveled some distance on its way up, some distance on its way down. So it's probably going to be useful to find the maximum height that it attained. The easiest way to do that is with the v squared equation. Equals v naught squared plus 2a delta y. This is to find the delta y. And notice, if we're going to be using our initial velocity as 12, and we want to know its maximum height, just like one of the earlier problems, then the final velocity will be 0, and then plus 2, negative 9.8. I got a little lazy there. Delta y. And so delta y is equal to negative 12 divided by negative 19.6. Oh, you know what? I know that didn't look right. We do need to square this. Excuse me. So negative 144. Positive. Okay, let's make sure I'm doing this right. So this delta y comes out to negative 12 squared. 2 times negative 1.8 delta y. Negative 7.35. Oh, I know the problem. Duh. So if this is squared and then I subtracted it over, I'm sorry. So that is negative, negative. It does not positive, which should be because this is the highest point. It is above where it started. So sorry about that confusion. I was trying to figure out where I went wrong there. So delta y is 7.35 meters. So what does that mean? From the initial release point to the top, it went 7.35 meters. We know that it came back down 7.35 meters, and then it went another 75 meters. So the total distance, 7.35, 7.35, and then another 75. So 7.35 times 2 is 14.7 plus 75 meters should give us 89.7 meters is the total distance traveled. Right. That looks good. All right. So that is that's no problem. Hopefully you'll understand that. The last one I want to do is number 46. All right, this one actually is one of your homework problems. So if you have not done number 46 yet, I would advise you to pause the video and do it, or give it a shot. All right, it's a little tricky, yeah, I mean, I gave you the answers on the Moodle, so it's definitely worth your time to try to get it yourself and then check. All right, so pause the video. Flip. Video paused. Awesome. So now that you've done the problem, let's take a look at it. A falling stone takes 0.3 seconds to travel past a window 2.2 meters tall. From what height above the window did the stone fall? So let's do this. So we have a window. Doesn't need to be that fancy. It says the window height is 2.2 meters. And it was dropped from some height above the window, right? From what height above the window did it fall? So it either fell or dropped. So somewhere up here, there's some initial position with an initial velocity, which is 0 in this case. And then here, there's a new velocity that we don't know. And here there's another velocity that we don't know. But we do know that it took a certain amount of time, 0.3 seconds, to travel that vertical distance. So we need to find this height above the window. So this is y1, and this is initial position and position, at this first point here. We need to find that displacement. So let me make sure this is straight on the screen. So why not do that? Cool. So we have this distance in this time. So let's go ahead and find the speed. So delta y over time. That is the definition of average velocity. Average velocity. So 2.2 meters divided by 0.3 seconds. And that gives us 7.33 meters per second. And that is the average velocity during this time. So it's important to recognize that that is the time it takes, or that is not the velocity here or here, but the total average velocity. So it's probably the velocity right here. And, well, no, it is, yeah, let's see. That is the velocity in the middle. And so it has a slower velocity here and a faster velocity down there. So I have worked this problem out already. So I'm going to show you how I worked it out. And there might be another way to work it out. I know in class, y'all guys in the front, Tristan, Luis, and Benny, and y'all had a different way of solving that problem than I did. There's probably a different way to solve this as well. There may be a different way, utilizing that fact that it's in the middle. But I want to show you another way, which again combines simultaneously two equations, two unknowns, to work it out. If we use the fact that the average velocity is the velocity at the first place plus the velocity at the second place divided by 2, right, just the average. And we use the fact, the definition of acceleration, which we know to be 9.8, to be v2 minus v1 over t. We can actually solve these equations for one velocity. Basically, we have two equations and two unknowns, so we can solve them. All right, so let's go ahead and do that. 2 times the average velocity equals v1 plus v2, or as we can subtract that. And the acceleration times time equals v2 minus v1. We add that over, so AT plus V1 equals V2, right? That's actually one of our equations. And this one, V2 equals 2V minus V1, 2V bar minus V1. So we can set these equal to each other. 2V bar minus V1 equals AT plus V1, right? We see V2 equal to V2. We can solve that around. Solving for V1, we have 2V1 equals 2V bar, this is the average, right, minus AT, and divide by 2, so our velocity is 1/2 of this, or V bar minus 1/2 acceleration times time. V bar is 7.33, we've solved that already, minus 1/2 negative 9.8 times time, which the time is 0.3, excuse me. And so we get that V1 is equal to negative 5.86 meters per second squared. So, and again, it's negative because yeah, it's going downwards. So our sign convention is still working out. What if it, and it works out? You're probably asking if this is negative. So the average velocity is downwards as well. So negative 7.33, and that will work out. So excuse me there. So now that we know this velocity, right, we can, knowing that the initial velocity is 0 and the final velocity here, since we know both the initial and final velocity, we can use any one of these three equations. We want the one to find the distance, right? We're trying to find this distance above the window which it was dropped. So we're going to go ahead and use this equation, which we can solve for distance. So V squared, and to be a little more precise, this is going to be the final velocity, V1 squared equals the initial velocity squared plus 2a delta y. So negative 5.86 squared equals 0. It was dropped or fell or whatever, to negative 9.8 meters per second squared times delta y. Delta y is what we are looking for. Do the math, and it comes out to 1.75 meters. And it is positive because it was dropped from above the window. So 1.75 meters above the windows from where it was dropped. So these are just a few more examples of using free fall to solve problems. And so hopefully the rest of the homework problems will be a piece of cake. I encourage you all to talk with your classmates, study together, exchange phone numbers, that sort of thing, and really do spend the time to work out the problems. Make sure you get the answers correct, and you will be successful. All right. So hope these videos helped, and I will see you guys in class on Tuesday. We do have a quiz, so have a good weekend.